My name is Haley Hopkins, and today we will be talking about the environmental Kuznets curve and its relation to air pollution. The environmental Kuznets curve, or EKC, was introduced by Grossman and Kruger in 1991 when they studied the potential environmental impacts of the North American Free Trade Agreement. It is a hypothesized relationship between income per capita and environmental degradation. It proposes that indicators of environmental degradation first rise and then fall with increasing economic development. As you can see on the graph to the right, it is shown as an inverted U shape with the maximum pollution per income per capita coming from industrial economies, which is where the turning point is. Going from left to right, the EKC shows that countries with low income have low pollution due to a lack of industrialization. As a country's income grows, it begins to industrialize, so the amount of pollution it emits increases until it reaches that turning point. The EKC assumes that after a country reaches this turning point, it will adopt cleaner technologies, and thus environmental degradation will slow and regress. In reality, very few countries have surpassed the turning point, as pollution acquired is extremely hard to get rid of, and it is also extremely expensive in some cases. So many countries get stuck at this turning point. When using the environmental Kuznets curve to explain air pollution, we see many inconsistencies throughout different emission types. The relationship between economic growth and the environment is not fixed. There are too many variables other than income per capita to take into account for this one theory to be plausible for every situation. Some of the variables that change the EKC include local emissions, atmospheric dispersion, and public awareness. With air pollution, it is extremely important to take into account transboundary pollution, which is a pollution that originates in one country, but causes environmental damage in another country. Southeast Asia has a high percentage of transboundary pollution, specifically the countries surrounding China. For example, long-range transport of air pollutants from China accounts for approximately 26 to 30% of the annual particulate matter in South Korea, as shown in the graph. Some examples of other inconsistencies include CO2 and SO2 emissions. The best example of this is CO2 emissions. For some background information, the atmospheric CO2 concentration has increased by more than 30% since pre-industrial times due to both industrialization and global warming. With CO2 and the EKC, the turning point is much larger than the current maximum income per capita. That means that there is not a single country that can surpass the turning point. Furthermore, there is no data to suggest that there would be a turning point in the relation between income and carbon emissions, even if they met the needed income per capita. All current data suggests carbon emissions will only increase with industrialization, as global warming has been increasing over the years. The graph shown is the EKC in the US in 1996, and as you can see, it never reaches the turning point and the environmental degradation only increases. Though most applied econometricians accept the Kuznets curve model, some critics have theories on why they believe the Kuznets curve is nothing more than a snapshot of the dynamic process. There are three main scenarios that would drastically change the way the curve worked. The first is believed to cause a horizontal line at the maximum existing pollution level, as globalization promotes a race to the bottom, which means increased economic activity leads to greater emissions of industrial pollutants and more environmental degradation. The second scenario suggests that unregulated toxins could have a detrimental effect on the environment, if not handled in a safe way, which is why we see the curve drastically increase in the case of new toxins. The third scenario is similar to the current Kuznets curve, but critics suggest that growth generates less pollution in the early stages of industrialization, and pollution begins falling at lower income levels, which causes the curve to drop and shift to the left. That being said, only the revised Kuznets curve scenario is backed by empirical evidence. The other two are merely theoretical. Personally, I think the environmental Kuznets curve is just a basic relationship between environmental degradation and income per capita, but I don't believe it can be applied to all situations, especially when talking about air pollution, as air cannot be contained. I also think externalities like transboundary pollution have a major impact on the EKC. The biggest conclusion to take away from this is that modernization of the environmental Kuznets curve is needed to reflect the modern realities of air pollution.